let's talk about today's lesson, which is radicals. We are talking this chapter 6, radical expressions and radical equations. And yesterday we learned how to apply the multiplication property of radicals. Basically, is this formula. Check this out. Nth root of A times nth root of B equals nth root of A times B. This is the formula. Sometimes you're going to apply this formula this way, on this order that you are joining together two roots, or you can apply sometimes the other way, that you have one root and you want to split in two different roots. I'm going to show now some examples. We worked this yesterday, and I would like to check if you remember. Okay, I have a few examples on the next slide. I will ask you to answer this and tell me what was going to be the answer. Let me just complete a few things. The first one, letter A, we are joining together two radicals, cube root of 3 times cube root of 9. The letter B, we are splitting, and is missing here, is the square root of 75, which is going to be equal to the square root of 25 times the square root of 3. Okay? And letter C, we are also splitting the fourth root of 112. Fourth root of 112, which is equals fourth root of 16 times fourth root of 7. Okay? Now, check, we have some missing numbers. I want you to answer. What are the missing numbers? What are the steps? The final step, actually, that's missing here. Okay? Send me a message. Let me select a couple of students. So letter A, the answer is going to be 3 because it's cube root of 27. Letter B, the answer is the number that's missing is the square root of 25, which is 5, and we keep the square root of 3, which is not a perfect square, right? You just keep it like that. And for letter C, anyone wants to try? Is the fourth root of 16. The number that's missing is the fourth root of 16. We keep fourth root of 7 because 7 is not a perfect exponent 4. It's not. We cannot factor it out. So it's fourth root of 7. And what's the number missing here? Does anyone wants to try? Is the fourth, and you can use a calculator. Okay? Yes, Kara. Perfect. You can use a calculator because 16 is 2 times 2 times 2 times 2, 4. The answer is 2 fourth root of 7. Perfect, Chiara. Thank you very much, Chiara. Thank you very, very much, Jada. Perfect answers. Very good. And I'm happy because you know how to work with multiplication property of radicals. If you're still a bit confused, you need to practice. Check the quiz from yesterday, review the quiz, and you can ask me for more questions, more exercises to practice. You can also go to Khan Academy and practice by yourself. This kind of thing you're just going to learn by practicing. But I'm happy to see that Jada and Chiara, they are doing great. Thank you. Okay, any questions about it? Let's move to the next thing, the next slide. Which is the topic of today's lesson. And today we will keep working on simplification of radical expressions. But today we're going to use the order of operations. And you're going to see this is kind of simple. I don't like to say it's easy or it's difficult, but it's simple because it's not that you have to do this way, but it's going to be easier if you do that way. Okay? Let me show an example, and maybe you can understand what I'm talking about. If you have letter A, square root of A 7 over A3, and you can apply multiplication properties and the properties of radicals and solve this. You can write like this. You can split this fraction as A exponent square root of A exponent 7 over square root of A exponent 3. You can do this, you can work like that, but you will have more work. You need to spend more time and have more efforts to find the answer, okay? Because you need to follow the order of operations. And the order of operations say, first you have to solve, to simplify what's inside the radical. And then you're going to apply, at the end, the properties of radicals to simplify, okay? The last thing you're going to do. So let's check. Not that you're not allowed, but again, because you're going to work more. It's going to be harder. So let's follow the right order of operations. And first you have to check if there's anything you can simplify on this fraction here inside the radical. And actually it is. You can simplify this and subtract from the exponent, right? So you can have, if you work out this division, this is the properties of exponents. If you have a division, you're going to subtract the exponent. So it's A exponent 7 minus 3, the square root, right? And this is going to be square root of A to the 4th. And now we can apply properties of radicals. Divide the 4 by the index 2, and you have the answer A squared. That is the right answer. See? It's going to be less hard, less work if you follow the correct order of operations. Sometimes even the order of operations can help us simplify and make it easier, and sometimes you really have to follow the order of operations or you're going to find the wrong answer. Let's make some stuff here clear. Follow the order of operations to make sure you work clever, work less, and find the right answer at the end. Questions? Let me show the next example, letter B. For letter B, we have cube root of 3 over 81. And again, same thing. You can apply cube root of 3 and cube root of 81 and do all the simplifications from here. But this is going to be the wrong order, the wrong thing to do, because you're going to work more. It's hard work. So let's follow the right order of operations and check if there's any simplification we can do inside the radical. And we have 3, let me repeat here, 3 over 81. We can divide the numerator and the denominator by one same number. To simplify, can divide the numerator by 3, the denominator by 3, and then the answer is going to be cube root, the next step, 1 over 27. Now we can apply the properties of radicals, and we can write like this. What is the cube root of 27? 3, yes. So 1 over 3 is going to be the answer, the simplified expression for letter B. Okay, let me show the whole thing, zoom out and show everything that we worked. Tell me, you have any questions? Do you think we can apply that kind of thing on the quiz? We have more examples or questions similar to this one, those on the quiz. If you have questions, you can ask me now, or even you can ask later during the quiz. But I think we are able to start and to apply this knowledge to work on some practice. Do you agree? Let's move on and practice. Any questions? If you have questions, if you have any feedback or any comments, let me know. If you don't have questions, let's move on. Send me now, before we start the quiz, send me your answers for the bell work. Send me your messages. Tell me what are your guesses. This is the way I've calculated. I wrote the expression and submitted both sides of the expression by the exponent 6. Then I simplified and find x equals 64. But never mind. Most of you got the right answer, 64. If you check, it is actually the square root of 64 is actually twice the cube root of 64. So congratulations, congratulations, you got the right. The quiz today is to simplify, write the answer as radical expressions, and do not use not decimals, and use positive exponents only. Let's try letter A, okay? For letter A, we can write this as square root of 25, applying the multiplication property, times the square root of b cubed, right? Correct? But square root of 25 is 5. And what about the square root of b cubed? Remember how to work this? Well, you're going to divide 3 by the index 2. So divide 3 by 2. If it is a perfect division, you have exact division, then you get rid of the roots. You find the answer and you don't have any roots. But if it's not an exact division, you're going to have a remainder. And this is not an exact division. 3 divided by 2 is 1. 1 times 2, 2. And then you're going to have a remainder of 1. The result is 1. The remainder is 1. So you're going to write b. And here is the result of the division 1. The square root of b. And next is the remainder. Let me use another color for the remainder. This kind of blue. And the remainder is 1. See? Here you have the result of the division, and inside the root you have the exponent is going to be the remainder. The answer is 5b square root of b. And now give me 1 minute. We will get back to work together. For letter J, well, you have to break down this square root of 18, and we repeat here 7 times 18. We have to break down into two numbers, 18. One is going to be a perfect square, so we can simplify it. And I'm thinking square root of 9 times 2. 9 times 2 is 18, right? Over 9. Because we can break it down 7 times the square root of 9 times the square root of 2 over 9. Because the square root of 9 is 3. 7 times 3, square root of 2 over 9. And 9 divided by 3, 3. The answer is 7 square root. 7 square root of 2 over 3. That is going to be the answer for letter J. And you're asking also letter O. Letter O. Check this out. First, try to simplify the most that you can inside the radical. So we have 300 that you can divide by 3 is 100. And we have y cubed. You can simplify by subtracting from these exponents, right? That means after you simplify, you're going to get rid of the numerator. The numerator is 1 now. And the denominator is 100 times y, 15 minus 3, 12. Now you can apply the properties of radicals. You can write this is 1 over square root of 100 times y, 12. And then you can break it down as 1 over square root of 100 times square root of y, 12. And this is equals 1 over 10 y, 12 divided by 2, right? This is 12 divided by 2, 6. So we have J and O, as you asked. Thank you, Ariel. J and O are on the screen. Let me zoom out a little bit more.